Okay, so let's look at properties of the unit circle and see what things it can help us work out. Right. So this is a unit circle, and what it means by that, its radius is unit, as in it's 1 unit long. Okay, so there's 1 centimeter, and so on and so forth. 1 centimeter or whatever it could, whatever you want. Now, let's say I measured this angle here. Then let's say I measure this angle theta, which is measured from the x-axis in an anti-clockwise direction. We always measure from the x-axis in an anti-clockwise direction. Now, how could I work out this coordinate using this angle and this length 1 only? Okay, how could I work out this particular coordinate using that 1, and let's say I measure that angle theta here. Okay, now if I drop a line down here, this may give you a clue as to what we're going to do. Okay, so if I drop a line straight down, I want to work out from 0 how much I need to go along and then straight up to get to this point, if that's the angle and that's 1. Well, what we have here is a right angle triangle, right? It's right angle there's got, if you go along and straight up, that's going to make a right angle. We've got a length of 1 there, hypotenuse of 1, and the angle is theta, right? Okay, and we've looked at this before in our previous clips. We know what this length is going to be. That's going to be cos of the angle, cosine theta. And then we know what this length is going to be. That's going to be sine of that angle, right? So this coordinate, if I wanted to work it out, its x part, how much I go along, is going to be cos theta, cos of that angle, and its y component, how much I'm going to go up, is going to be sine theta. So its x component, I'm going to go along cos theta, and then I'm going to go up sine theta. Okay, and just to prove that, here's a bit of software, GeoGebra. It's going to work out various things for me really quickly. So at the moment, it's doing 2 things. At the moment, this coordinate here, it's telling me what the coordinate is. The computer's just going to telling me what it is. It's 0.7 across. So this length is 0.7 and it's 0.71 up. Okay, so it's 0.71 up here and 0.71 along. Sorry, 0.7 along and 0.71 up. But it's also doing an extra thing for me. It's working out this angle here, which is 45.43. Again, that's the angle here made with the x-axis in an anti-clockwise direction. And it's also doing cos of the angle for me. It's going to do cos of 45.43. And it's rounded it really to 2 decimal places. So it's telling me it's 0.7. So cos of 45.43 is 0.7. And then it's also doing sine of the same angle. Sine of 45.43 degrees is 0.71. And you can see they match up. That's matching with that and that's matching with that. And no matter what I do, if I move it here and change the angle to 66.45, cos of the angle is the same as that x component, and sine of the angle is the same as the y component. And it doesn't matter how much I change it. So 15.36 is the angle, and then there you go, it says 0.96, 0.96, 0.26, 0.26. And if I do it smack bang on this point here, 90, cos of 90 is telling me 0, and sine of 90 is 1, and you can see the coordinates are 0 along and 1 up. But it works no matter what I do. Even if I go past this point into this quadrant, okay, you can see the angle's turned into an obtuse angle, 132.33. And cos of that angle is minus 0.67, and then there you go, it's minus 0.67 here. And then same thing for the sine of the angle, 0.74, 0.74. So it works no matter what I do, okay. If I stop it here, you can see they still match up. And if I change it to exactly 180, cos of 180 is minus 1, minus 1. Sine of 180 is 0, 0. And it works even if I go past that point. You can see they still match. Even if I go to 270, you can see 0, minus 1. And if I go past 270, they still work. And even if I go, well, if I go back to 0, it'll work even if I did 370. If I went past and I did cos of 370, it'll still be the same thing, right? So you can see it works no matter what. So even if the angle's obtuse or a reflex, it works no matter what. The x component is always cos of the angle, and the sine of the y component is always sine of the angle, no matter what size the angle is. Okay, now what does it help us do? Let's look at what it helps us do. So let's look at this unit circle, okay, a brand new one. Now first of all, let's label key angles on our unit circle. Right, 0 degrees. Now let's say it was a flat line, that would be 0 degrees. Sorry, that's 0, the origin there. Okay, and let me do it in a different color. Okay, so that would be 0 degrees. And then this would be 90 degrees straight up. Okay, but 90 degrees in radians is pi over 2. Okay, so pi over 2 in radians. And then this point would be 180 straight across this way, 180, or pi, that's just 180 is pi in radians. And then this would be 270 degrees, or that would be 3 pi over 2, and then back to 0, which would be effectively 2 pi as well. Oh, sorry, hang on. Back to 0 degrees, or 360, which is 2 pi radians, right? Okay. Now, if I had an angle in here, theta, okay, this is my angle theta, okay, the theta here would be less than pi over 2, let's work in radians, pi over 2, but greater than 0. Okay, we know the component, the coordinates are cos theta, that's the x component, cos the angle, and then sine theta, right? Okay, that's what we've discussed above. But let's look at the values. If theta is somewhere between pi over 2 and 0, between 90 or 0, we know that if you look at where this coordinate is, okay, it's going to be along something and up something. So this value is going to be positive. So cos of that particular angle, whatever it is, going to be positive, and sine of the same angle is going to be positive as well. So sine of it's going to be positive, and cos of it's going to be positive. Now, well, what about tan of the angle? Okay, but remember from our trig identities clip, tan is the same as sine over cos, right? Sine over cos. Now, if this is positive and this is positive, and we divide it here, we do sine of the angle divided by cos of the angle, we're dividing a positive number by another positive number, so this is also going to be positive. So tan of a particular value is going to be, tan of a particular value between these two parameters is going to be positive. So all three things here are positive, or all of them are positive, all. Okay? They're all positive. So for example, tan of 30 degrees, tan of 30 degrees is definitely going to be a positive value because it's between 90 and 0, or pi over 2 and 0. So tan of 30 is definitely going to be positive. Right, so they're all positive here. Now let's go along a bit. Let's go to an angle which is an obtuse angle, which is, okay, so theta is less than pi but greater than pi over 2. So it's an obtuse angle. So it's greater than 90 but less than 180. Okay, an obtuse angle. That's theta here. So let's look at this coordinate again. So the coordinate again is, cos theta is the x component, sine theta is the y component. Okay, and tan theta is going to be made up by dividing those two, right? Dividing that by this. Alright, but if you look at the coordinate, its x component is going to have to be negative, right? It's going to be negative. Because we're going along from 0, we've got to go into the negative x part. So cos of 90, so if the angle is somewhere between 90 and 180, cos of it is definitely going to be negative. But the sine of it remains positive, so this remains positive. So we have a negative and a positive. But if we divide those two, okay, remember, tan theta is sine over cos, so if we divide that by this, a negative divided by a positive, it's going to remain negative. So it's going to be negative. Right, so what do we have here? Only the sine of an angle between 90 and 180 remains positive. The other two, cos and tan, remain negative. So only sine is positive here. Let me do that in orange to keep it consistent. So only sine is positive here. Okay? Right, so if you had, let's say the angle was, okay, something like 140, let's say. Right, let's write down the key thing, three things. Cos of 140. Okay, well that will be negative for definite because it's greater than 90 but less than 180, so it's going to be definitely going to be negative, right? Sine of 140, well, as we discussed, that's definitely going to be positive, and tan of 140 is definitely going to be negative. Okay, and if you can check that on a calculator, you'll have some decimal, but sine of cos of 140 will be a negative answer, and then this will be positive. All right, let's go on to a little bit more. So we're going past 180 but less than 270. 270. So we're looking at angles which are less than 3 pi over 2 or 270, but greater than pi, so greater than 180. Now let's look at the components here. Okay, so remember the cos theta is the x part and the sine theta is the y part of the coordinate. Now, if you look at it, we're in the negative x-axis component, so the cos theta is going to be negative, and we're also in the negative part of the y-axis, so sine theta is going to be negative. But what happens to tan theta? Well, tan theta is this one divided by this one. Well, two negatives, okay, a negative divided by negative is positive. So that means tan theta is going to be positive here. So after the three, sine, cos, and tan of an angle bigger than 180 but less than 270, tan is the only one that remains positive. Sine is negative and cosine is negative. So tan is the only one that remains positive. Okay, let's go to our last quadrant. Okay, so our last quadrant is theta is an angle that is greater than, is less than 2 pi, less than 360, but greater than 3 pi over 2. And let's look at the coordinate. Let's look at the component here. So here's a component. Here's a coordinate. Sorry, cos theta, sine theta. Right. Well, if you look at it, we're going from 0, going along. Okay. So cos theta, the x component is going to be positive, but we're going down to get to this angle. So the sine component is going to be negative. So we have that the cos of an angle greater than 270 but less than 360 is positive, and sine of the same angle is going to be negative. But let's look at tan. Tan is going to be sine divided by cos, so it's going to be a negative number divided by a positive number, which is going to be negative, right? So tan is going to be negative. So let's kind of sum it up, right? So let's pick a random angle. Tan, let's say theta is something like 250 degrees. Okay, 250 degrees. Right. Well, so it's between 270 and 180. So let's look at the cos of 250, sine of 250, and tan of 250. We know what sine is going to be just based on this. Now, the way I remember this this sort of okay, so the only one that remained positive here was cosine. Sorry, I forgot to put that in. The way I remember the three quadrants of the triangle is all of them are positive. Only sine is positive, only tan is positive here, and only cosine is positive here if the angle is this sort of angle, okay? The way I remember is all silly turtles crawl, okay? So that's how I kind of remember the ASTC to determine which one's positive. So what we have is this. 250 is in this quadrant, in the quadrant T here, okay? It's this sort of angle, an obtuse, it's an angle bigger than 180 but less than 270. So the only one that's going to be positive in this quadrant is tan, and the other two are negative. So let's just check that. Okay, so let's do cos of 250, okay, is minus, and then sine of 250 is also minus, but then tan of 250 is a positive number. And there you go. Okay, so remember the all silly turtles crawl to remember which one's which. So they're all positive here. Only sine is positive here. Only tan is positive here, and only cosine is positive here.